Hi guys, I just want to show you how to do the energy skate park. I know I said I would do this in my office hours on Friday, and then I realized that Friday is a WOW day, so we don't have office hours tomorrow. So if you go to Science and you scroll down, if you open up the Module 6 Energy folder by clicking this arrow right here, if you scroll down, the Energy Skate Park is this assignment right here. It says Energy Skate Park 226. And when I click on this, it says go to the Energy Skate Park website and complete the Google Doc. Open the Google Doc, click make a copy, and then share it with me. So I'm going to click on the Energy Skate Park website. And when I do, I see that I have the intro. You're going to click on intro, and then you have this little skater guy here. And if you put him on the ramp, you'll see he goes back and forth on the, oh no, I'm going to put them back. The other thing I'm going to do is I'm going to click the pie chart so I can see the kinetic and potential energy. And then I'm going to click the bar graph as well so that I can see how the kinetic and potential energy are transforming back and forth. And then I'm going to click on speed as well so that I can see his speed and how it's increasing and decreasing. You can click on the grid if you want to, just so we can see the height. Excuse me. So then what we're going to do now is, now that we have this going, is we're going to go back to the assignment on Buzz. We're going to click on the Google Doc. And when you do, it asks you to make a copy. So you're going to make a copy. And then the very first thing that you need to do when you make the copy is go up here, hit that blue share button, and share this assignment with me. That way when you turn it in, I can access it and I'll be able to grade it. So this is just showing you what it should look like, and you should have these options checked. When we look down here, it says play with the simulation and then answer the questions below. You can see that you've got several questions here. One is, what is potential energy? And then that answer will go here. So you're just going to put the definition of potential energy. Over here, it says, when does the skater experience the greatest amount of potential energy? If you go to the skate park and you watch, you can see this changing. So when the circle graph is full in blue, that means he has the most potential energy. So I can see by looking at the graph that his potential energy is the highest when he is at the top of the ramp. So if I go to my Google Doc, here I would type in definition of potential. Over here I would say at the top of the ramp. The next question is kinetic energy, and again here, what is kinetic energy? You're just going to put your definition here. And then over here it says, when does the skater experience the greatest amount of kinetic energy? So again, we'll go back to the graph. Kinetic energy is in green. So where in the graph does he have the highest amount of kinetic energy? If I put this in slow motion and I watch, and I pause it right here, I'm trying to get right there. So I can see that this is all green right now. So this is where he has the maximum amount of kinetic energy. So that would be at the bottom middle of the ramp. So if I go back here, I would just type bottom middle. All right. The next question, it says, does the total amount of energy, the yellow bar, ever change, and why do you think this is? So let's go back. I'm going to take it out of slow motion, put it on normal, and this time I'm not watching the kinetic and potential, I'm watching the total amount of energy. And I can see that this bar is not changing. This bar stays constant the entire time. And that is due to the law of conservation of energy, which states that energy cannot be created or destroyed. Question 7. What happens to kinetic and potential energy when you increase the mass of the skater? So for this, you're just going to change his mass. So let's make him really small. All right, and we watch. It does look like the kinetic and potential energy did decrease when I made his mass smaller. Now what happens if I increase his mass? And look what happened to the kinetic and potential energy. So it definitely did increase. So increasing mass increases the kinetic and potential energy that the skater has. So question 8, when does the skater move the fastest? And look at the speed of the clock. Okay, so for this, it doesn't really matter what his mass is. I'll just put him back in the middle. What we're looking at is speed. So if I'm watching him go back and forth, I can see the speed every time is like right there. All right, and then so if I look at this, then he's traveling the fastest when he has the maximum kinetic energy. So see, if I pause it right there, that's right where that speed is the highest. So he travels the fastest when his kinetic energy is the highest, which is at the bottom middle of the ramp. And then question number 9, when you increase the mass of the skater, does it make the skater go faster? So again, we're going to be looking at speed. This time we're going to increase his mass and see if his speed goes any higher. And it doesn't look like it. So the speed is staying the same. What if I make him really small? Does he slow down? No, he doesn't. So his speed is remaining constant no matter what I do to the mass. So the mass is not changing the speed. So if I go back to the Google Doc, that's what we would type. We would say no. When you increase the mass, does this make him go faster? No. And how do you know? And it's just by looking at the speed. We can see that it doesn't change. So the right today, the speedometer doesn't change. All right. And then once you have all of these questions answered, you've already shared it with me, hopefully, then you guys will just go back to Buzz, scroll all the way down, and here you hit that blue plus sign that says attach Google Doc, and then submit that Google Doc, and that's your Energy Skate Park assignment. If you guys have any questions, you can always send me an email if you can't figure something out. So thank you, and I will see you guys Monday.